Good morning, children. In our previous video, that is in number system part 1, we covered from natural number system to definition of rational numbers. In this video, we are going deep into the rational number system. Let us recall the definition of rational number system. Set p by q where p, q are integers and the denominator q not equals to 0. And in fraction a by b, the a is called numerator and b is called denominator. Let us recall few concepts in our previous classes. Types of fractions. Proper fraction, that means small integer by big integer. Example 1 by 5, 3 by 8, etc. Mathematically we say that a by b, we know the condition b not equals to 0. The numerator a is less than the denominator b. Improper fraction, big integer by small integer. Examples 13 by 4, 6 by 5, etc. Mathematically we say that a by b, the numerator a is greater than the denominator b. Mixed fraction, it is nothing but another form of improper fraction. Improper fractions can be converted into mixed and mixed can be converted into improper. Examples 3 and 1 by 4, it is equals to 13 by 4. 4 into 3, 12, 12 plus 1, 13, 13 by 4. 3 and 1 by 4 is mixed. 13 by 4 is improper. Similarly, 1 and 1 by 5 is equals to 6 by 5 and 2 and 3 by 4 is equals to 11 by 4. The form of mixed fraction is integer and proper fraction. Now, we can convert a rational number into a decimal number by dividing the numerator with denominator. That means, suppose there is 1 by 2. The numerator is 1. We are dividing it with denominator 2. In this process, we get decimal fractions. Let us observe some decimal numbers. 1 by 2 is 0.5, 1 by 3 is 0.3333, so and so on. The repeat 3 repeats, so it is written as 0.3 bar. 7 by 5 is 1.4, 7 by 6 is 1.16666, so and so on. It is written as 1.16 bar. Now, these are of two types. They are terminating decimals. Example 0.5 and 1.4. Some more examples 4.25, 0.75, 3.6, etc. Another one is non-terminating recurring decimals. That means 1.123 bar, 1.123 bar, 1.123 bar. Note, the ending zeros of decimal number can be dropped. That means 2.500 is equals to 2.5. The ending zeros can be dropped. Dear students, note carefully. 2.005 is not equals to 2.5 because these zeros are not ending zeros. One more thing. Fundamental theorem of arithmetic. Every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Don't worry, the fundamental theorem of arithmetic is nothing but any compound number can be prime factorized, and that prime factorization is unique. The order may vary from one to another. Let us take an example. 120 is a compound number. It can be written as 2 into 60. Again, 60 can be written as 2 into 30. Again, 30 can be written as 2 into 15. Now, it is not divisible by 2. What is the next prime number? Yes, 3. So, 15 can be written as 3 into 5. What is the last result? 2 into 2 into 2 into 3 into 5. All are prime numbers. That means every composite number can be written as factors of prime numbers. So it is called prime factorization. Now come to terminating decimals once again. If the factors of a denominator of a simplified fraction contains 2 or 5 only, then it is terminating decimal. Example, 11 by 16. It is a simple fraction. It cannot be simplified further. Now take denominator 16. Prime factorize it. 2 into 2 into 2 into 2. It contains only 2's. So 11 by 16 is a terminating decimal. One more example. 9 by 25. It is a simple fraction. It cannot be further simplified. So denominator is 25. Prime factorization is 5 into 5. It contains only 5. So 9 by 25 is a terminating decimal. Similarly, 13 by 50. Denominator 50 is 2 into 5 into 5. Contains 2 or 5 only. So 13 by 50 is a terminating decimal. Now come to non-terminating recurring decimals. If the factors of a denominator of a simplified fraction contains other than 2 or 5, then it is non-terminating recurring decimals. Example, take 11 by 24. Prime factorization of 24 or 2 into 2 into 2 into 3 contains other than 2 or 5, that is 3. So it is non-terminating recurring decimal. Similarly, one more example, 9 by 70. 70 is 2 into 5 into 7, contains other than 2 or 5, that is 7. So 9 by 70 is non-terminating recurring decimal. Dear students, look here, 1.123 bar. That means 123, 123, 123 repeats. The repetition digits are called period. Here the period is 123. The periodicity, the number of digits, how many digits are repeating? 3. So the periodicity is 3. Now come to next one, 1.123 bar. Here period is 23 and periodicity, the number of digits are 2. Similarly, 1.123 bar. Period is 3, periodicity is 1. Now let us solve a question without actual performing long division. That means don't do long division like this. State whether the following rational numbers will have terminating decimal or non-terminating repeating or recurring decimal. If it is terminating, then only convert it into decimal fraction without actual division. Now, the first question is 9 by 15. Step number 1, simplify the fraction. 9 by 15 becomes 3 by 5. Now, prime factorize the denominator. The denominator is 5. It is already prime number. So, we need not further prime factorize it. If the denominator contains 2 or 5, then it is terminating. So, the 9 by 15 is terminating. And he asked that 9 by 15 is terminating. He asked that if it is terminating, convert it into decimal. Now, equalize the denominator squares of 10 or cubes of 10. That means 10, 100, 1000, 10,000, etc. Then convert it into the decimal system. Example here, 9 by 15. After simplification, it is 3 by 5. Now we want to convert the denominator 5 as 10. How it is possible? Possible by multiplying with 2 at both numerator and denominator. Then it becomes 6 by 10. 6 by 10 is 0.6. Let us go to one more example. 143 by 110. After simplification, it becomes 13 by 10. It is nothing but 1.3. And 64 by 455. It cannot be simplified further. Now take the denominator 455. By prime factorization, we get 5 into 7 into 13. Here we have 7 and 13 other than 2 or 5. So it is non-terminating recurring decimal. Now one more example. 3 by 16. 16 can be written as 2 into 2 into 2 into 2. Hence it is terminating decimal. How can we convert it into decimal fraction? How many 2's are there in the denominator? 4 2's. So multiply with 4 5's in the numerator, at the same time 4 5's with the denominator. It becomes 1875 by 10,000. It is nothing but 0.1875. Now converting the terminating decimals into fractions. It is very simple. We know that if 6 is equals to 6 by 1, and also we know that 7 is equals to 7.0 and 7.00 and 7.00, so and so on. We use this one here. Here we are converting 0.125 as a fraction. 0.125 is nothing but 0.125 by 1, and the denominator 1 can be written as 1.000. Now we can eliminate the decimal point, because after decimal point the number of digits are same. So it becomes 125 by 1000. By simplification, it is 1 by 8. One more question. 1.25. It is nothing but 1.25 by 1. This 1 can be written as 1.00. So it is 125 by 100. By simplification, 5 by 4. And 12.5. 12.5 can be written as 12.5 by 1. It is 12.5 by 1.0. Now it is 125 by 10. After removing the decimal point, we get 125 by 10. By simplification, it is 25 by 2. Thus, we can convert terminating decimals into fractions. Now we are going to converting non-terminating recurring decimals into fractions. We have some steps. Carefully observe the steps. First, assume the given decimal number as x. Carefully examine the repeating decimal or period. Step number 3. Place the period to the left side of the decimal point. Step 4. Place the period to the right side of the decimal. Step 5. Subtract and simplify. Let us go to the example. Question is 0.236 bar. According to the step number 1, assume it as some x. Here the period is 6. In the step number 3, it is said that place the period to the left side of the decimal point. That means it is a period. So the decimal point should come to here. The period should be left side of the decimal point. So left side of the decimal point. So the decimal point travels 3 digits. That means multiply with 1000x. 1000x becomes 236.6 bar because 6 repeats continuously. So 1000x is equals to 236.6 bar. Now the period should come right side of the decimal point. That means the decimal point should travel 2 digits right side. So it is 100x is equal to 23.6 bar. Now subtract. By subtracting we get 900x equals to 213. So x equals to 213 by 900. By simplification we get 71 by 300. Children, let us go to one more question. 0.236 bar. Here period is 36. Now period should be left side of the decimal point. That means 0.236 bar. This period should be left side of the decimal point. So the decimal point should travel here. How many digits should travel to right side? 3 digits. So multiply with 1000. 1000x becomes 236.636 bar. So because the period is here 36. Now the period should be right side of the decimal point. So 10x is equal to 2.36 bar. Now by subtraction we get 990x is equal to 234. So x equals to 234 by 990. By simplification we get 13 by 55. One more question. 0.236 bar. Here the period is 236. The 236, the period should be the left side of the decimal point. So the decimal point should travel 3 digits. So it is 1000x is equal to 236.236. Now x is equal to 0.236 bar. Already here the period is right side of the decimal point. Now simply we can subtract. Now it becomes 999x is equal to 236. So x is equal to 236 by 999. Dear children, we learnt that the rational numbers are two types. They are terminating decimals and second one is non-terminating recurring decimals. Now the question is, do non-terminating non-recurring decimals exist? Yes, they are called irrational numbers. In our next video, we will learn about irrational numbers. Dear students, if you have any clarification, please call me, and thank you very much.